Alrighty, good afternoon, ladies and gentlemen. Happy Monday, or whenever this catches you. Today we're going to cover and bridge our understanding from that 4.1 lesson that I did on patterns um, into something a little bit more mathematical, which is referred to as a linear system. So, what I'm covering in this video specifically, the two big things are two ways of graphing linear equations. So you're going to learn two methods of how to graph. They're good for different things. Both are equally good to know. I use a combination of both when I do them, depending on what the equation I get is. And then secondly, finding the equation of a line. One thing to remember, when we were talking about a pattern number, I gave sort of a formula. So if I had the pattern 4, 7, 10, 13, 16, and so on, if I wanted to say find the 10th pattern number, I could say the value of the 10th would be equal to how much I change by. So I look at what I call the step amount. So how much do I change by each time I add 3? So in this case, I have positive 3, and then pattern times the pattern number. So this is a multiplication. So in this case, I want to know the 10th. So I'm going to multiply by 10. And then finally, there was this starting value, which I had said was actually the value before our starting one. Because if you think about it, when we count, this is the pattern number 1 when we start at 4. So we start counting, we go 4. So what did I start from if I go up by 3 each time? Well, I would be starting to count from 1. So this would be my pattern 0 value. So this equation would be 3 times 10 plus 1. So I would do the math and I would get the value of 10 would be equal to 31. So we're going to use this and we're going to kind of bridge this gap when we deal with linear equations because we're going to be dealing with a more general pattern now. A few other things I want to go into. When we talk about a linear equation, oftentimes we're looking at comparing two or more values. So this happens all the time in real world. This is something like money versus time. You could think, if you're thinking about physics, we have time versus distance or distance versus time. Basically, anytime we have a graph where we're comparing two things, this is a relation or an equation between two or more variables. I don't necessarily know how much money I have or how much time it takes, and oftentimes as one of those changes, so too will the other one. The other thing I want to mention is that we have a coordinate system and there's this thing called an ordered pair. Now, in your reviews, I saw you all kind of ace this section, so I'm not going to spend too long on it. The important thing to remember is if I have an ordered pair, what I am referring to is, say I have the point 1 and 3, the first value is referring to my x value and the second is referring to my y value. So an ordered pair is always going to go x, y. Eventually, if you go and follow math and you go into 3 dimensions, there's going to be an x, y, and then a z axis. So you're going to go x, y, z. So 1, 3, I would find 1 on the x and I would find 3 on the y. So the point 1, 3 corresponds to this point right here. The other thing is that we have a very special point at the origin, which is at the point 0, 0, and that is our point right in the middle of our graph where our x and y axis comes from. So this point right here is the point 0, 0. Here they give a couple of examples of how we map different ordered pairs. We have the 4 quadrants. This is covered in our foldable, so I'm going to skip it from here. And then we get to our first major concept. So there's two forms that we generally find a linear equation in. The first one is referred to this slope-intercept form. So the equation that you'll see oftentimes told is this y is equal to m times x plus b. So the two things that I'm interested in right now, I have y and x, which should kind of stand out to our x and y axes. So oftentimes those x and y's are going to represent something, but the m and the b are sort of new letters. So the m refers to, in this case, is what we like to call in math our slope. Now, if we think about slope in terms of like a real world scenario, slope means like a hill, or like you hit the slopes when you go skiing. So you can think about it as slope is sort of a measure of the, I'll call it the steepness. of a line. Now, we give it a very specific definition. We say that it is equal to the rise over the run. So how far you go up and down divided by how far you run. So think about which ways you rise and you run. You rise up. When you rise in the morning, you stand up. When you run, you don't run up, you run horizontally. You run along the ground. So this is how far you change going up and down versus how far you change going left and right. They have a more mathematical definition, which I'm going to get into just a little bit, but y2 minus y1 over x2 minus x1. Important thing is that we're looking at the change in y versus the change in x. The other one that's important for us right now is our y-intercept. So our b stands for our y-intercept. Now, again, we think about the term intercept and what it means outside of math. So the best idea that you can come up with is when two things are intercepting each other, it means that they're going to meet at some point. If you're a fan of sports like football, a good analogy would be an interception is when someone throws the ball and someone from the opposite team catches it before it reaches the destination it wants to go. So if I think of an interception, I have my person throwing a ball and it's going, and then for someone to intercept the ball, someone has to catch it before it reaches the ground. So right here, the two people have met. This is a crossing of a point. So in this case, our y-intercept refers to two things intercepting. And the letter y should give us an indication. This is the point the line crosses the y-axis. And really all we need to know are these two things for us to be able to graph our line. So I'm going to go into the example that they give here. So I'm going to just move over so you can take these notes alongside. The first method I'm going to show you is what I like to call the staircase method, and you'll see why in just a moment. This works well for slopes that have fractions, so I'm looking for my m is a fraction in this case, and an integer y-intercept. So no decimals in my y-intercept, so in this case I have y is equal to negative 2 over 3 times x plus 4. So I have a nice whole number here, and then I have a staircase, or I have a rise and a run over here. So the other two important things is that m in this case is equal to negative 2 over 3, which is equal to my rise over run. And this will be important in around step 2 or 3 of our staircase method. So, okay, how we can go about graphing this. First up, I'll point out when you see a linear equation, you're not trying to necessarily solve for y or x, because as x changes, so too will y. So you're actually going to have an unlimited number of solutions, kind of like how when we had our pattern of numbers, we had an unlimited pattern of numbers. I'm thinking of this sort of like a pattern number compared to what the value of that pattern number actually is. And you'll see this comes up in just a moment. So number one, I'm going to plot my y-intercept. So this is sort of my starting value. The reason why is that I know it's at the point 0, b. And I'll show you why this is the case, but keep in mind, I am looking for the point where my line crosses this vertical line here. At any point here, it has a very special x value. In this case, my x is always going to be equal to 0. Always. So if I want, I can plug in x equals 0. So I would have y is equal to negative 2 over 3 times 0 plus 4. And you can see right away this is going to be almost trivial to solve. I have negative 2 over 3 times 0. Well, anything times 0 just vanishes. So then what I'm left with is just the positive 4, or I'll just write 4. Now keep in mind, I said before that this was our b value here. Now it doesn't matter what my slope is. When I multiply a number by 0, and because I know that my y-intercept will always be x equals 0, I can just simply take this second number here. So I end up with the coordinate 0, 4. So I'm going to number these 1, 2, 3, 4, 1, 2, 3, 4, -1, -2, -3, and then -4. So I'm looking for the point 0, 4, which is right up here. So I have my 1 point. Next up, this is where I start to use the staircase. So I'm going to use my m is equal to my rise over run, which is equal to -2/3, to basically solve for how I'm going to move along this line. So if I look at it, I rise by -2 and I run by 3. And I always kind of follow the pattern. I'm going to the right. So when I follow this, which way do I go, up or down? Well, if I'm rising by -2, rising by -2 means that I end up going down 2. So sorry, I'll make the line a little bit thicker. So I'm going to go down 2 and I go over 3. So I run 3 and I rise by -2. And what I want to do is plot at least 2 points. I'll say 1 to 2 points. So once I go down to over 3, I'm going to make a new point. So this is conveniently at the point 3, 2. It doesn't have to match up. If I was to do this again, what you'll notice is that I'd have to extend my graph. So I would have to go 5, 6. So I could follow it again and I'd go down to over 3 and I would make a third dot here. Our last step is to connect our dots and add arrows to both ends. So I'll grab this. Now, why I want 3 points, I'll get into in just a moment. But you'll notice that the 2 points will work and I can plot them and add arrows. A couple of important things. We need to add the arrows. So this is an absolute must do, because whatever we draw is just going to be just a portion of the line. And this line is going to go on forever. It's going to go on in both directions, so I need to make sure that it's going up and to the left and down and to the right. Now, one of the things that you can use to help you out here, and I'll give you a summary at some point, but if we have 2 options for slope. We can have positive slope, which goes up and right, and negative slope goes down and right. And where this comes from is the idea of us reading from left to right. So if you imagine, I like to think of it as if you have a person and you have 2 lines, which way are they going up or down our hill? So if you have a positive slope and your person is walking to the right, they're going to be going uphill. And then if you have a negative slope and they're walking right, we go downhill. And we read graphs left to right, just like how we read sentences left to right in English. Now, why I want 3 points is very simply because if I have 2 points on a graph, sorry, I'll put them here, it is 100% of the time you can draw a line between the 2 of them. However, that does not mean that your line is correct, because one of those 2 points could be wrong. So why I want 3 points is because if I have 3 points, there's now only one way that these lines can work. If they're all perfectly lined up, then it should be obvious to see that it works. If one of my things is wrong, so say I accidentally plot the points here, now you can see there's no way that I can connect these 3 dots with a straight line. Whereas before I could easily connect, I now have to either go like this, or I have to go like this, or it has to curve. And one of the things to keep in mind is that linear equations, one thing that I always like to think of is that they spell linear equations. So they form a straight line. So if you start realizing that you have to graph a curved line, then something wrong has happened and that one of your points is wrong. And this third point will allow you to double check to make sure you're right, because if they're all perfectly lined up, then it'll work, just like I have here. And you can see that because I had to estimate this one and I had to hand draw it, it's not going to be perfect. So I do recommend using graph paper just so you can accurately use this check. Okay, the second method, table of values. So I have a second example here. This one it's good for everything, so I'll say it's more flexible. So you can see some of the issues with this is that if I have, say, like a y-intercept of 3.2, I know it's going to be somewhere around here, but that's hard to accurately measure. And because I'm basing all of my points off of that starting value, you can see that it's going to be challenging. So in this case, we're going to make a table of values. So number one, make a t-table comparing x and y. So I'm going to make a t-table. I'll have x here and a y value here. 2 is, and I'm going to be a little bit loose with my language, pick nice numbers for x to solve for y. So when I say nice numbers, what I'm referring to is we're looking for things that make our math easy. A good one that'll always generally work is x is equal to 0. And we saw this before, that if I plug in 0, then it makes this part go away. So if I'm graphing y is equal to y is equal to 3 over 4x minus 2, what I would do is y is equal to 3 over 4 times 0 minus 2. This goes away. So I end up with y is equal to negative 2. And I take that value and I put it over here. The reason why I want to solve for x and not y is because I already have all the math on one side. I have y equals a bunch of stuff. It's much easier than to pick a value for x and solve for y than the other way around. Now, when I say nice numbers, I could pick the number, say, 1. So, for example, if I did x is equal to 1, then I would have y is equal to 3 over 4 times 1 minus 2. Okay, well this you can see 3 over 4 times 1 is going to give me 3 over 4 minus 2. Oh, well, okay, 1 second. So I have 3 over 4 minus 8 over 4. So this would be equal to y is equal to negative 5 over 4. So if I wanted, I could do 1 and negative 5 over 4. But that's not a great number to use. So what I mean by this is I want to pick numbers that make my math easier. So for example, I could pick the number 4. Now the reason why I'm doing this is if I have y is equal to 3 over 4 times 4, this is really 4 over 1. This is going to cancel out with the 4 in the bottom. So then I end up with y is equal to 3 minus 2. So I end up with y is equal to 1. So I have the number 1. This is really nice to solve rather than this. And then I want to solve for 3 points. So I already have 3, but I'm going to pick one more. I'm going to pick minus 4. So I can pick negative numbers just like I can pick positive numbers. So I now have negative 4 here being multiplied. And I actually like to pick numbers that are opposite. So if I pick 4, I like to pick -4 because it's going to make the math almost identical. Now I cancel out here, but now I have a negative times a positive. So I end up with y is equal to -3, -2. So I get the value y is equal to -5. Oops, -5. So I'm going to put that value here. And now what you can see is what I actually have if I put these in brackets is a bunch of ordered pairs. I have a value for x and I have a value for y. So the last step is plot, connect, and add arrows. Oops. So I'm going to find the point 0, -2. I'm going to find the point 4, 1. -4, -5 is going to be down here, so I have to extend this out a little bit. And then lastly, so this is 4, 1. This is 0, -2. This is -4, -5. And then lastly, if I try to plot this one, I have 1 and then -5/4. So this is -4/4. So 5 out of 4 would be like a quarter of the way down. And you can see here that if I have my ruler, these almost perfectly line up. The only one that was a little bit off was my point down here that I had to make. Now you can see if I was to do this as a sort of a staircase method, I'm rising by 3 and running by 4, so I go over by 4 and I go up 3. If I go the other way, I'm still going over 4, up 3, but now I'm thinking about it coming from the left-hand side. You can see I'm still making that staircase. This point here doesn't actually fall on one of those perfect staircases, but you can see how it would work, how it still matches the values because it's in that line. So this is our second method. The reason why this works nicely is if I don't get nice numbers to start with, I can pick values that make my line much easier to graph. I don't have to really rely on that slope being a nice value. Okay, so these are the two methods. They have their strengths and weaknesses. I would encourage you to learn both. The other thing I want you to connect with is let's look back at that equation that we started with. If I think about the step amount, this is the amount our pattern was changing, my starting value. Well, this, I have something equals a thing multiplying, and then I add something on. If I look at the form y is equal to mx plus b, a couple of things stand out. My starting value was where I started at here when my pattern number was equal to 0. Well, if I look at my b value, that was when my x was equal to 0. And now we can see stuff is starting to line up. This is when x is equal to 0, or my pattern number was equal to 0. Well, my pattern number is right here, which matches up with my x. My y is sort of my result, or what my value is for any given x. And then this is how much I change by. Excuse me. So lastly, what I'd like to kind of show you is that this pattern is just an extension of what we started with. This is my pattern number value. This is my step amount. This becomes my pattern number. And finally, this is my starting value. So we're moving away from this sort of generalized form of the equation now to something that gives us all the variable possibilities that we can plug in. So keep this in mind. It's not any harder than what we were doing before. It's just using x and y. So now we don't have discrete steps where we're going from pattern number 1 to pattern number 2. We're now examining every possibility. So we're looking at the ones in between. The other thing to keep in mind, and this will come up in just a moment, the last thing I want to show you is we now know how to graph a line. What happens if I'm given a line and I need to work backwards? So one of the questions I'd like to give you is, how do we deal with this? So if I have a line, I'm going to do question D because I'm going to assign the other ones. My strategy that I like to use is what I call the reverse staircase. This is a nice way to find the slope and y-intercept. So find, I'll say 2 to 3 points on the graph that meet integer values for both x and y. So my first step, the reason why finding an equation from a line is hard is I don't have any numbers to deal with. So this one I have to find 2 to 3 points, preferably 3, but 2 will work, on a graph that meet at integer values for both x and y. So what I mean by that is I'm looking for a point where they cross and a whole value for both. So I'm looking for where the line crosses at these sort of intersections. So I see that there's 1 point here, and I see that there's 1 point here, and there's 1 point here. So I'm just gonna label these for me. So this is 3, 3. Excuse me. This is the point 0, 1, and this is the point -3, -1. So once I have my 3 points, number 2 is identify y-intercept if possible. And remember, we're looking for where it crosses the y-axis. So we're looking for 0, something. So in this case, I actually have a discrete value. Now it's if possible, so in this case it is, so I have 0, 1. So I can say right away is that b is equal to 1. I'm basically starting with y is equal to mx plus b, and my goal is to solve for m and b. One of the things that makes this hard too is that we generally like to solve all the variables, but we're only solving for 2 of them. So currently, in my answer, what I have is y is equal to mx plus 1. Now, to solve for m, what I want to do is build a staircase to go from point to point and put rise over run. So in this case, I'm going to go from this point here to this point here, and from this one to this one. So I'm basically building this reverse staircase to see how far I go over and up. If I look at my rise, in both cases I go up 2, and in this one I go over 3. So if I go rise over run, I'm looking at 2 over 3. So in this case, this is our m. And then lastly, I can put it all together. So my answer is going to be y is equal to 2 over 3x plus 1. And this is what I mean by saying we don't need to solve for everything. This is actually the equation of our line. Think about what we start with when we have to graph a line. We aren't given y or x. We're instead given m and b. So this is as far as I need to solve. Now, there is a step 4 that's related to step 2. So if I say I deal with question F, and I look at the points that are given, and the 2 points that show up are here and here. If I look at where my line crosses the y-axis, it crosses at this sort of midway point. I can probably guess that b is equal to -0.5. That's like roughly halfway in between. that it's at the point 0, negative 0.5. But again, I don't know. And there's not much of a difference between negative a half and negative 0.501. So I want to be certain that I'm correct. So instead, I'm going to skip 2, and I'm going to look at my rise and my run. In this case, I only have 2 points, so I could keep going, but I'd have to extend my graph. In this case, I run by 2, and I rise 1, 2, 3, 4, 5. Excuse me. I have something caught in my throat, I guess. So in this case, my m is equal to rise over run, so 5 over 2. The other thing I'll point out, both of these lines are going up and to the right, so I don't have to think about the sign. I know that both of these are positive values. If it was a line like this that's going down and to the right, then I would have a negative slope. Okay, so I have this, so I have y is equal to 5 over 2x plus b. So step number 4 is, if b is not easy to solve, plug in a point on the line and solve. So what I mean by that is pick a point and we're going to solve for b. So in this case, we have 2 points. I have the point 1, 2, and I have the point -1, -3. Now both of these will work for solving. I don't like dealing with negative numbers, so I'm going to use this point here. So I'm going to use 1, 2, which means that I'm going to plug in x equals 1 and y is equal to 2. So plugging these into this equation here, I end up with the following. I have 2 is equal to 5 over 2 times 1 equal or plus b. So I have to solve for b. So first thing, I'm going to multiply these together. So I have 2 is equal to, well, this is easy, 5 over 2 plus b. So I'm going to take away 5 over 2 from both sides. Again, opposite operations. And what I'm going to be left with is that b is equal to 2 minus 5 over 2. So I get b is equal to, if I turn this into over 2, I have 4 over 2 minus 5 over 2. So I get b is equal to -1/2. Oh, that was actually what I was saying over here, and I can see that it's right around here. So lastly, I can plug this value in, so I have y is equal to 5 over 2x minus 1/2. Alternatively, if you prefer decimals, it's totally valid for you to go y is equal to 2.5x minus 0.5. If you do one in decimals, do the other one in decimals. All right, so the last thing I want to point out is specifically with this one here. So a lot of people get worried about which points they pick. So say for whatever reason we lost this point here. I'll undo that later. I only have this point and this point. Now we might think that that's going to change our slope, but if I look at it, I have a run now of 1, 2, 3, 4, 5, 6. I have a run of 6 and a rise of 1, 2, 3, 4. So if I look at my original run of 3 and rise of 2, notice something special about them. If I do rise over run, I now have 4 over 6. Well, 4 over 6, that actually reduces to 2 over 3. So one of the things to keep in mind is that it doesn't matter which points we pick, so long as we pick 2 points that are clearly identifiable. So the other thing that you can kind of notice is that one staircase that's twice as long and twice as high can be split into 2 stairs that are half as big. And that's all we're doing here. So for homework, what I'd like to give you is some practice for here. So 4 and 5, these are our mild. Basically, 4 is we're plotting points, 5 is we're doing the opposite, we're given points and we have to find their coordinates. This is just a bit of practice and review. Our medium is 6, we'll do ACE, and 7 ACE. 6 is a bit of a review, so you have a point and you have to plug this in. So basically what I would do is I have x is equal to -2, y is equal to -1. I'm plugging in into this equation, and I'm going to see if my answer makes sense. If it makes sense, I'll have something like 1 equals 1, and if it doesn't make sense, I'm going to have something with like 1 equals 4. 7, you are given values. You're supposed to figure out the empty values here next to them. So I'd plug in 0 for x over here, solve for it. I'd plug in 0 for y over here, and then solve for x. And then lastly, 8, we're graphing. So these are equations of lines that I'd like you to graph. The one extra that I'll give you is h. It's a little bit on the spicy side, just because it isn't currently in our proper format. Lastly, 9, this is the start of our spicy where we're finding an equation of a line. And some word problems, just to make it interesting, is 10 and 13. So there's some practice for you today. On Wednesday, I'll probably be posting either section 4.3, which is a different way of graphing, or I'm going to jump ahead to chapter 6 and deal with interpolation and extrapolation just so we can get a head start on that section. In any case, that's all I have for you today. Thank you so much for listening. Take care. Have a good one. Bye.